Hello, everyone. Thank you for joining this Innovate2Build session. In this session, we're to be discussing the benefits of using a management information system for steel fabrication. My name is Tommy Moussis. I'm a technical solution architect with GRAITEC. And my main role largely with GRAITEC has been to support steel fabrication companies, detailing firms, and engineering firms implementing hardware, software, and IT solutions throughout North America and previously the United Kingdom. In this session, we're to be taking a look at the main challenges of a steel fabrication shop, the common pain points, and how using a management information system can solve a lot of these common issues. First, let's take a look into the steel industry and the function of a steel fabrication shop, the main objective, if you will. Now, there's two sides to the coin. Okay, so there's the client, project, and construction side, and their wants and needs. So steel is defined on a project level. So any sort of steel project, it can be an envelope of just one portion of the building. It can be the curtain wall, the main structure. It could be the miscellaneous steel. It could be the entirety of the project, depending on size. So they're going to be defining the requirements, and they can request that the deliverable is in lots or phases. And of course, they want a certain safety and quality regulation standard to be accommodated with the deliverable. Now, the steel fabricator's objective here is to deliver only the specified parts to the project, no more, no less. It's just whatever is specified by the general contractor or customer. That is what is to be delivered. But a challenge for the steel fabricator, of course, for profitability is to be able to take on multiple projects at the same time, simultaneously, and optimize their resources. And by resources, it could be not only human resources, but of course, the materials and so on. And another challenge is to handle these commercial changes on every project. We'll say not every project, but on most projects, there could be change orders, revisions made to the design in the middle of the project. So the steel fabricator needs to be able to handle these changes, extras attributed, revisions, etc., whilst still communicating this seamlessly to the design department and making sure that these changes are communicated clearly to the workshop to avoid the discrepancies, mistakes, and waste of material. Now, here we're seeing the root cause analysis. So all the different tasks that a steel fabricator would take on, and this is excluding design. Okay, this you're just looking at everything from customer inquiry all the way to delivering steel. Now, there's many different tasks, and of course, if there is no system in place like a management information system, ERP, or manufacturing execution system in place to help facilitate communication between departments and manage these tasks, there's a lot of areas where information or there's a lot of areas where misinformation can be passed along, or mistakes can occur due to human error, etc. Now, the main pitfalls can come about with just the upfront information and being able to receive the steel data efficiently from the general contractor and or engineering firm or detailing firm, etc. Now, we'll take a look at what the steel data typically looks like here. So it comes from the engineer's design intent. Even if you're working with the general contractor, of course, it could be another engineering firm contracted to the project. This, again, can be internal as well if you're offering the full turnkey. But it's the engineer's design intent that gets passed down to the detailed design. Now, once again, a fabricator can have a detailing department, which would then read the engineer's overview drawings and then bring it to a higher level of detail. From there, you would extrapolate the 2D drawings, if you have a BIM modeling software, for example, like Tekla, at Autodesk Advanced Steel, SDS2, you can then model it in 3D, but then ultimately still to extrapolate the 2D drawings, generate bill of materials. And for a fabrication shop, the smallest form of information pertaining to the fabrication process are the part marks. So those are the identification numbers associated to all the components in the project. Now, the identification numbers are hypercritical. They're very important for sorting data, not only for the understanding of what needs to be fabricated, but later on when executing other tasks like truck loading or creating your fabrication orders. Delivery notes, invoicing, any task like that, it all correlates back to the identification number. So this is actually a very important component to organizing the information and being able to communicate back to the general contractor or internally where components are at all times. Now, typically the part marks are devised of 4 different items, so they could be the role of the item. So there's typically a prefix to act as an identification of what the function is of that set item in the project. So, for example, B for beam, C for column, and then the numeric value that's applied. There's a few different ways that you can apply this numeric value. It can be based off of a simple counter method, meaning it's just counting in process of elimination or counting in sequential order all the items in the project and then just associating an individual number. Now, of course, if they're similar items, they can have the same number as well. But if there's 2 items that are the same in different phases, you might want different numbers associated. There's many different strategies that you can apply to the numbering sequence of an item. But what's most common, at least in North America, is associating the assembly to the page number. And other parts of the world, they can just decide to have just a numeric value applied. Again, this is based off of geo and also based off the company itself and what they're used to as a process. And of course, if it's a larger project, you would have another prefix to the prefix, if you will, which would be the identification number associated to the lot and or phase. Now, this is what happens in the upfront. So when we talk about customer inquiry, it's really about receiving not only the information pertaining to the project, but when receiving the engineer's design drawings, if you're not offering the full turnkey, you're then first detailing the project, bringing into that level of detail required for fabrication. And when detailing, you're assigning all the different part components, these different numbers, to then be able to facilitate management of the project in the workshop, in the purchasing department, on the shop floor, and in the shipping department as well. Now, what are the common pain points of managing all actions within a steel fabrication shop and, of course, sorting all this data? The common pain points are job tracking, inventory visibility, quality control, traceability, and profitability. These are the 5 main pain points, not only if you don't have a management information system, but they're just the common pain points for any fabrication shop in general. So with job tracking, having visibility and knowing where the projects are at all times is usually a pain point. With every steel project, there's many different components. Some can be subcontracted if you don't have the means of fabricating that specific item in-house. And knowing where the status is of all those components that have been subcontracted, that are on the shop floor, that have been expedited for galvanization, it's usually a pain point to keep keep visibility and traceability on those actions. In addition, you have the variable of managing multiple projects at the same time. So it's very easy to lose sight of where you're at in a job. Inventory visibility. If you don't have any system in place to track your inventory by means other than Excel spreadsheets, Google Sheets, and things of this type, of course, there's going to be inconsistencies. There could be workers in the shop that that pull material off the racks that are not necessarily associated to that said project because it wasn't assigned to a project correctly, etc. Material can maybe be pulled off the rack to build jigs to facilitate items for welding, and so there can always be inconsistencies in inventory visibility, and of course just by the basic nature of a workshop, there could be materials stored out in the yard, on the racks. So if you're unsure as to what you have in stock, you'd have to send an employee down to actually verify, and this can take a lot of time. So inventory visibility is always a challenge if you don't have a system in place to have traceability and to have live feedback on what's going on in inventory. Quality control is also something that can be very difficult. Most mistakes, when they do happen, it's hard to identify where they've come from, if it was coming from the design drawing, if there was a change made in the sales process, meaning a revision allocated to a project that wasn't communicated well. There's always difficulty with finding where the issue came about and when. And of course, having traceability on quality control and reception of materials, if there's any damages, and capturing these damages and assessing them at the right point in time, it's always a difficult challenge. Traceability, so having traceability on all the documentation associated and tasks as well associated to the project is just always a common pitfall. Profitability, of course, with all these ongoing issues, they all link back to profitability. So when mistakes are made and a certain amount of time is spent on the project, correlating that data, if it's not tracked correctly, back to the original estimate is always a difficult task. It's a Herculean task, and knowing truly what margins were made on a project is always difficult. Which means it's difficult to make the right decisions for your business for the following year. If you need to hire that additional employee, if you need to buy that additional machine, visibility on profitability or the true profits on every project is always a little bit difficult. Excuse me. Now, the common pain points by profile in the business, and again, for a steel fabrication shop, there could be one individual that wears multiple hats depending on size. If it's a small to mid-sized business, it's common for one individual maybe to be doing two different jobs at the same time. With that said, the common pain points for an operation manager is to understand what projects are ongoing in the shop, if a project is complete or not, what is the status, can we invoice for that specific portion of the project, etc. Is there discrepancies? Why did they have it? What's the root cause? A sales manager, it typically they're more concerned with the estimates being accurate, the time related to the cost analysis. So estimates, of course, on a project can take an exorbitant amount of time depending on the size, and there's always there's always a need to have this process be quicker, especially if you're bidding on a project and there's other bidders involved. You always have a time constraint on delivering the information. And coordination and tracking documentation relating to tenders and orders is always a challenge. There's a lot of documentation that gets involved with a steel fabrication project. There could be legal documentation, design drawings, etc. So it's always difficult to keep track of versions post project awarded even. And then, of course, production management, planning and scheduling multiple projects at the same time, the general logistics management of it all, and to make sure that your shop is optimized at all times as well can be quite the challenge. Tracking machinery maintenance as well. So downtime of machines can of course impact your productivity. And if you don't have visibility on when you need to assess or maintain those machines or change bits, whatever the case is, that could slow down production. You have to have a forecast on that. And follow up with employees, making sure everything is done on the right time is just the basic challenges of a production manager. When we take a look at the logistics and delivery manager, of course, on-time delivery is key to avoid penalties. This is clear, but some of the other challenges could be missing pieces. So knowing if if something was loaded onto the truck, or if a piece has gone missing, where has it gone? Why has this happened? Fleet management. So if you're managing, of course, the site erection, just managing your employees and making sure they're going to the right location at the right time. Can be difficult, and maintenance and stock management. So delivery and logistics, sometimes it can be managing a reception as well. So the shipping department, and indirectly they could be involved with stock management, because they're managing the reception of materials from their vendors. And of course, another common pain point or profile in the business would be the BIM manager. So making sure what is designed can be produced in-house is something that usually the design team will identify. And of course, knowing and at that stage if it should be subcontract or not, and relaying that information is hypercritical, and could be challenging sometimes because there could be a misunderstanding between the shop manager and the owner. Let's say that everything should be fabricated in-house before the project is awarded. Uploading customer orders manually to existing ERP systems. So this is something that we see quite commonly. If you don't have an ERP or a management information system in place to be able to easily receive data from the design department, it can be difficult to compile all the necessary information into customer orders. Of course, with BIM solutions, you can have a bill of materials that extrapolate all the necessary information to your project, but uploading that data into a customer order can typically be a manual entry task, and that's where human error can come about, and with that discrepancies in what should be ordered for the project, and just there's a plethora of issues that can come about with that. Revisions to the project once they're already in production. So this is always a challenge in the design department, making sure that all the revisions are taken into account, and version controlling the drawings can be a task, and making sure that everybody receives the correct information at the right time. And managing information sent to the purchasing department as well. So then the exercise of nesting is usually done by an engineer or someone in the design department, if there is a design department. And with nesting, you want to execute nesting maybe on multiple projects at the same time to have your orders be simplified for the purchasing department. And there could be, if there's a discrepancy there with ordering too much material, not enough material, it's not the blame game, but it always can come back to either head of purchasing or the designer, depending on who's responsible for that task. But we see commonly now with solutions on the market like Advanced Steel that the designer will tends to do a preliminary nesting of some sort to identify how many bars are required for purchasing for that for the materials associated to that project at least. Now, with everything that was suggested there, what would fix the problem? So, of course, the means of receiving steel information directly into a software, that can be very useful. Keeping track of it all through the sales and production cycles. Again, if you had a software that would be able to manage all that information, that would be beneficial there. And ensuring correct delivery, quality, time, and quantity is of course, this may be redundant, it's necessary, yes, but having a solution in place to touch these three main pillars would obviously fix the problem. Now, some sub items that you would need here, of course, when you're receiving the steel information into a software, you want to be able to divide into the smallest unit of work. So you want to not only compile everything into a customer order, but you probably want to be able to segregate that information easily into fabrication orders, and here process numerous small units of work. Once again, fabrication orders is hypercritical. Now, in the previous pillar, you can even decide to break it out to multiple customer orders, at least in the solution that we're going to talk about in just a few minutes, and ensuring the correct delivery, quantity, and time. So delivering various combinations of work units and being able to manage that would be a huge fix this problem as well. So we're to talk now about a GRAITEC solution and how using a manufacturing execution system, ERP, or MES can solve a lot of these problems. So we're to talk about GRAITEC's solution, Advanced Workshop. So this is, there can be a couple of different ways that you can call this solution. We call it a management information system because it does a lot more than just a manufacturing execution system, but it does a little bit less than an ERP. So this is why we call it a management information system. Now, what Advanced Workshop is an on-demand business solution for manufacturing companies. Now, today we're talking about Advanced Workshop Steel, so the solution that's focused for steel fabrication shops. And again, you can consider this a manufacturing execution system, plus, meaning with a lot more functionality, or you can look at this as an ERP. The only two things we do not manage in our solution is payroll and general ledgers, okay? It is a multi-architecture solution. What this means is you can have multiple companies, factories, and warehouses linked to a single database. Of course, we manage multiple units, languages, and currencies, but when we take a look at the functionality coverage, we cover many different processes from sales, purchasing, credit control, job sites, invoicing. In the technical office management, we have BIM integration. So we have interfaces to be able to import data from the CAD department directly into our software. And of course, we manage the bill of materials. And within those bill of materials, we manage not only the list of items that need to be purchased with the SKUs built in the system for the raw material items that would need to be purchased, but we also factor in operational times and costs. So we can also manage real-time production monitoring. We have different applications that can be deployed in the workshop along with hardware such as PDAs, touch boxes, and or tablets to have full traceability in the production. And we can manage the stock in a multitude of ways with barcodes, PDAs. We can track stock by geolocation as well. So there's a lot of there's many different modules and workflows that can be accommodated in our system. Regarding the payroll and general ledgers part, we always integrate with other solutions. So we have the ability to export data, and we have done integrations in passing with solutions like Sage, SAP, Oracle, Microsoft Dynamics, etc. Advanced Workshop can accommodate many different workflows, but in its when you look at the general breakdown of information, it's quite simple. When first receiving information pertaining to a project, or if you wanted to bid on the project, first you would create your customer profile, then create the job site associated to the project. And then from there, of course, if the project is then awarded, you can import the BIM files or the metadata pertaining to that project by means of certain different types of formats. We'll talk about that a little bit later on. And then you can manage the structural elements. When I say manage structural elements, meaning you can manage the part routing, which departments are going to process said components, and also if they're going to be subcontracted, if material needs to be purchased. So there's a lot of different touch points there when I talk about the elements here. And then once all the management is done to organize the information, then you can extrapolate the fabrication orders for your workshop. And we even have features to be able to drive NC data directly to different servers or drives on servers for those in the shop. Now here, when talking about the elements again, there's a few other tasks that you do regarding purchasing. So you would purchase material, have those tracked in stock. Now, of course, when you can just allocate stock directly to the customer orders, but if there's no stock available, there's other modules in the solution to facilitate tasks like nesting to identify what material needs to be purchased for the project. And of course, then you can receive the material. You can have it tracked afterwards in stock, and then assign it to the project upon reception. And then with NC data, we can drive this to what we call touch boxes that can be linked to machines. And of course, we manage everything all the way down to the delivery notes and invoicing. So this is why we call it a management information system. It's a combination of ERP functionality, MRP functionality, and MES functions to have a truly tailored vertical solution for steel fabrication companies. So again, just to circle back and summarize, an MES for steel fabrication is going to give you the ability to have a visibility and full control of production. This can be by means of manual or automated methods with the application. Automated meaning if you have a combination of PDAs and touch boxes in your workshop, you'll have an automated traceability on actions once you scan the documentation or scan barcodes, etc. We can update the system automatically. But if you just wanted to use the Office application, you could still manually track everything, but still have good visibility between all the different departments. Automate assignment and order routing, welding management. So these are other aspects that will give you full control of production, being able to see which department is handling which task at what times, or workstations, I should say, as opposed to department. Time evaluation and workload calculation is something that's executed automatically. Stock management, post-production analysis, production planning, and of course, we have a link with Autodesk Advanced Steel. So these are all the advantages that you would get with using management information system for a steel fabricator. What Advanced Workshop Steel is meant to be is your single source of truth. So again, we're covering all these different actions, but the benefit here is that you have a real connected workflow afterwards between departments, as opposed to using Excel spreadsheets, Google Sheets, and working in silos. Everyone is then connected to a single database and has visibility on the actions that they need to take at that point in time to follow the critical path and deliver the items with on-time delivery, of course. Now, what we'll do is give you a quick overview of the import mechanism and give you an idea of the look and feel of GRAITEC Advance Workshop. So we'll just go ahead and start with the Autodesk Advanced Steel model. So here I have a smaller model just to make it easier to see all the data that's going to be imported into Advanced Workshop Steel. Here, if I double click on one of the components, the column here, I could see that part marks have been applied, but just to be sure that everything is numbered, we're going to go here to the output ribbon, click on numbering, and then here apply part marks to both the single parts and assemblies. Once that's done, then here we can go over to the export and import ribbon and export either an SMLX file, or you do have the option to, of course, export simply the NC files. So there's many different ways to import data into Advanced Workshop. Okay, but the example today we're to take a look at is Autodesk's Advanced Export, which is SMLX. This is Autodesk's, for those who don't know, this is Autodesk's BIM file format to facilitate communication with other structural steel platforms. Now, when I say structural steel platforms, I should say platforms that can manage structural steel elements. For example, Revit, Plant 3D, and of course, Autodesk Advanced Steel. These are all modeling solutions that could have structural steel in the model, and this is the main file format that you would use to facilitate communication between those platforms. A side note, GRAITEC has a solution called the Power Pack for Advanced Steel, and it's important to note that we have our own BIM file format called GTCX. And why this is important to note is, of course, Autodesk can make changes to their own file formats. It's just important to note that GRAITEC supports our customers with our own BIM file formats. In case any changes are made, we want to be sure that all customers can, of course, import data from Autodesk Advanced Steel at all times. And we support that through the Power Pack for Advanced Steel. Now, what I'll do is just go ahead and export. This SMLX file here, save it. And now we'll go into Advanced Workshop and import the file. So this is GRAITEC Advance Workshop. GRAITEC Advance Workshop, again, is a very robust solution. There's over 700 different menus and modules to be able to manage different workflows and various sets of information and different processes, etc. But the UI is generally very simple. Here we'll have a ribbon on the top just to execute main tasks such as validate information, close windows, search for information, create new entries, modify entries, etc. So we're mainly going to be staying on the actions ribbon throughout the entire presentation. And here I already have a custom order created that we'll use to just import the data. So if we go to the customer orders table, of course, whenever opening up a menu, you always have many search filters that can appear, and the UI is quite customizable. So I have many columns of information here. If I wanted to, I could just turn some off. But let's just go right into the customer order here. Now, from here, you want to set a certain information, for example, your payer customer, the job site file. I predefine those elements to speed up the process. But once you've selected your customer profile, a lot of information will be populated automatically based off that customer's profile. And of course, the job site information will be compiled automatically when selecting the job site that you want to link to the customer order. Now, here under items, you'll find an icon called Import 3D Steel Model. Once we click on this icon, it'll bring up this UI where you can select the import file type. Here we can see the different options, SMLX, NC. This can be, of course, NC, NC1 files. We can import Tekla models as well with the combination of NC1 files and XSR files. Of course, we have GRAITEC's a native bin file format called GTCX, and we can import IFCs. Here, I'll go ahead and select the SMLX file that we just exported. And now here we can see all the data compile into this this interface. Okay. Now there's a lot of information here. As you can see, it's extrapolated all the metadata, but added links with the data within Advanced Workshop as well. So whenever you see a column that is gray, this is data coming from Advanced Steel. Whenever you see a column that's white, this is information from that's being driven from Advanced Workshop. Okay. Now, it's done in association automatically to items or SKUs within Advanced Workshop automatically. So we have a mapping mechanism which will save entries. So once you've linked a part component to a SKU, when I say part component, I'm talking about the general section type and plate thickness, etc. Once you link it to a SKU, it'll create that preliminary link for future use. Why I call it a preliminary link is, of course, because when you go through the exercise of nesting in your database, you can have different SKUs that you would order from your suppliers that could be of different lengths. So meaning if you were, or to simplify, if you typically order bars of 20 feet, but your supplier can provide you also 25-foot lengths or 30-foot lengths, this is something that you can pick and choose later on when you get to the exercise of nesting. But as a preliminary link, you're more concerned with just the section type and being linked to an appropriate SKU, so that you can get the preliminary data relating to material consumption and, of course, operations that would be applied to the item. Now, here you're also seeing this cell here to produce. Now, if we take a look at this operation, this is welding and tack welding. If I needed to subcontract any operation, I can just go here to the menu and click on subcontract. We can set this to be automated for certain types of operations. So if you always want to subcontract certain operations or for specific section types, whatever the case is. This is something that can be controlled with our part routing mechanism. And here you're seeing green check marks. What this means is these items are passing the feasibility check. So just with our import mechanism, we're able to identify what items can be processed in our shop, and if there was any items that showed up with a red X, those would not be able to be imported for whatever reason. Maybe there's the weight of the profile exceeds the allowable amount, or maybe the length is too long for the for that said machine, and those profiles you typically subcontract for it to be processed. There could be many different reasons, but the feasibility check here is working in alignment with the operations that are allowable in your shop, and height, length, and weight restrictions by item type. Now here, if we collapse this folder that's linked to this part component, we can see here the operations and the machine that's going to manage said task. And another important point to note here is that we have a viewer. So if you're a service center or a fabricator that doesn't have a detailing department, when importing data from a detailing firm or an external firm, you could maybe have a detailer in-house, but are subcontracting the detailing portion of that project. Here we have a UI that'll help you identify the different part components and quality control before importing the data. So meaning if you're reviewing the PDF files, but then you're using this UI to import, you'll want to be able to quality control the part components and be 100% sure prior to importing that the part components are true to the design drawings that you're reviewing. Here we can see a summary of all the items associated to the project, and you can see the quantities and weights, of course. And you can also import in process of elimination. So you do not have to import the entirety of the model. If I wanted to select assemblies that were a part of a specific phase, I can go here and select just a few assemblies. This is just mimicking. Of course, there aren't any phases associated to this smaller project, but if there were, I'd be able to see the breakdown by phase and just import an entire phase if I wanted to. Now, once I've selected the items I want to import, I'll just go here, click on import. And just like that, all the data pertaining to those 5 assemblies has been sorted, and it's even giving me theoretical values to the cost. Now, why I call them theoretical values is because we have predefined times per operation and costs associated by workstation. And of course, there was the material consumption, the preliminary material consumption that was executed, but we don't know the true bars that we need to order, etc. So that's why these are theoretical values. With that said, if you want to see the process route requirement analysis for these items, then here we can click on this icon and see the breakdown of the assembly. We could see here the operations that need to be executed, the time related to each operation, the sections or SKUs that need to be used to order the material. And then here we could see the quantity and the units pertaining to the quantity. So the units can be in hours, seconds, by bar, by weight, foot length, weight per foot, etc. And then here, of course, in the other tables, you could see the consumption of material and the scrap or the waste. Now, if of course a bar exceeds X in length, we have the ability to track that remnant in stock afterwards. But this is where you can see the preliminary data pertaining to the process route requirement analysis. Now, from there, you can, of course, go and start scheduling your manufacturing production planning. So just to give you a quick idea of what that would look like, here now in this table, we'll have the different assemblies associated to that customer order, and you can choose to drag them and drop them on the date of your choosing. So here, I'm just going to take all assemblies associated to customer order 208, drag them and drop them to start as soon as possible. If I wanted to start them tomorrow, I could put them here, but then there's, of course, a few steps that we need to do to verify if we have stock, and if, of course, our workshop has hit critical mass or not at certain departments. Maybe I would need to start this fabrication order next week. This is depending on our capacity. Here in Advanced Workshop, you can always view the production planning. View this menu here, overall production planning, and see the capacities at each workstation, and also view the part components that are linked to said workstation and times associated to processing of those components. Here you can also see downtime for machine maintenance. And once I've decided that I can indeed process these components on Friday due to my shop having availability, I can then here choose to refine things and maybe associate different part components to certain workstations. Now here I'm opening the automatic assignment menu. In this menu, you'll be able to, once again, control which part component is going to be processed at which workstation. Now, for example, here for the assemblies, I have 2 welding stations, and I can choose to have the this assembly be fabricated at welding station 1 as opposed to welding station 2. If I wanted to subcontract a specific operation, now, of course, in our import menu, you could choose to subcontract at that level. However, if you've imported it and suggested that everything's going to be produced in-house, but then after you realize that your shop has hit critical mass and it's a rush project and you have no choice but to subcontract later, you can always choose to subcontract the entirety of the assembly if you wanted to at this level. If it's just a component, you could subcontract the components, or you could subcontract the individual operations. Once that's done, here we can go to the nesting module and verify if we have the materials in stock to produce the assemblies. Now here I'm seeing that first of all, I have many different ways of viewing the information. I can see the stock in hand, customers, reserve stock, available stock, expected stock from a supplier, and then the theoretical stock. So here clearly I would need to order material in order to produce this fabrication order. So what I can do here is base this off of an infinite quantity, meaning I don't have the materials in stock to nest. So I just want to base it off of an infinite quantity to see how much material I would need to order. And then just by clicking on automatic nesting, it's going to compile that information. And here I'm able to see not only the quantity of bars that would need to be purchased, but also I can see the part marks associated. And here you may notice that this portion is in red, so there's only 2.5 inches more or less of scrap of this material. But if something exceeds the predefined length to be thrown back into stock, so if there's a remnant that you would want to use on future projects, you could set predefined minimum values for bars. And here my settings are for 2 feet. So because here this length is exceeding 70 inches, so 73 inches, it's suggesting that this is an item that will need to be put into a stock afterwards, or we want traceability on that remnant. Once the nesting is done, I can then validate. And then go on to purchasing the material. So these are just a few different menus and just a quick look at the types of actions that can be managed in GRAITEC Advance Workshop, and some of the key features that would save an exorbitant amount of time and human error at the upfront. Just being able to link the design department to the purchasing department and workshop provides a high level of visibility and reduction in human error. With that said, I want to thank you all for joining this Innovate to Build session, and we can go ahead and begin the Q&A session.